used to store the excess energy during an intra-cycle fluctuation. In case of engine, normally the fluctuation of speed is due to intra-cycle or due to inter-cycle. Now what is the difference between intra-cycle and inter? Intra-cycle means you are executing for single stroke. So this one is your compression, this one is your suction, this one is compression, this one is power stroke, and this one is exhaust. So this complete one cycle. So whatever the fluctuation is caused during one complete cycle is called as intra-cycle. And if you are operating a power plant throughout the day and your load is changing with respect to time, we have a load cycle from 6 am to 10 am. Load is low during 6 to 10. So during this, load is slow. Now for this one, your load will be very low. From 11 onwards, from 10 onwards, up to, we can say up to 9 p.m. the load is peak. Or we can say up to 6 p.m. the load is higher. So load increases suddenly. And from 6 p.m. to 9 p.m. the load will again increase. Up to 12 p.m. the load will start decreasing. And it will become very low at the time of 12 to 6 p.m. because maximum establishments are closed. So we are working from 6 a.m. to 10 a.m. During this there are number of cycles. This one is for one cycle. So if you are able to maintain the speed of the turbine over the range of cycle, it is called as intercycle. And if you are able to maintain the speed constant over the one cycle, it is called as intracycle. Now these cycles are basically consist of thousands and thousands numbers of such cycles. From year to year, we are operating at 6 am to 10 am. So number of cycles are going on. We are not bothered what about the one cycle, but we are bothered about what 6 am to 10 am. So as the speed will increase, we are using governors. The governor, and for this one we are using the flywheel. Flywheel is used to control the one cycle speed changes, and governor is used for very long range of cycles. You can summarize like this: the function of the governor is to increase the supply of working fluid going to the prime mover when the load on the prime mover increases, and to decrease the supply when the load decreases, so as to keep the speed of the prime mover almost constant at different loads. So as we see here, the load is going to be changed. If the load is low, it will supply less fuel. The load will increase, will slightly increase the fuel supply. When the load is very high, we will increase the quantity of the fuel supplied or steam supplied in case of thermal power plant, and the load will decrease. We again decrease the quantity. Thereby you can control the power development. When the load of the engine will increases, the speed will also decreases. Therefore, it is become necessary to increase the supply of working fluid, either steam or either coal or either fuel. On the other hand, when the load on the engine decreases, the speed will increases, and hence less working fluid is required. The load will increase when the speed will decrease. Why so? Because the energy was supplied in the form of what? Current. Flywheel is a wheel which stores and releases the energy and to avoid the fluctuation in speed. It controls the fuel supply when the speed is in excess or very less through the centrifugal action. The flywheel, as said, stores the excess energy and releases the same energy when required during the idle stroke. A governor cannot store energy. That is the main difference. Governor just controls the fuel, the amount of fuel supplied or amount of working fluid supplied to the prime mover. Whereas flywheel is able to store the energy, and energy is always stored in the form of kinetic energy. The flywheel will minimize the fluctuation of speed within the cycle, but it cannot minimize the fluctuation due to load variation. To minimize the fluctuation in the mean speed, which may occur due to load variation, the governor is used. This means that flywheel does not exercise any control over the mean speed of engine. The governor has no influence over a cyclic speed fluctuation, but it controls the mean speed over the long period during which the load on the engine may vary. Work done is defined as integral of F multiplied by displacement. This one is for translational, and for rotational case we have integral of T times d theta. That is the area under versus crank angles. Torque versus crank angle. And normally crank angle is always used in radian. So whatever the diagram we called it, we normally called it as turning moment diagram. On y-axis we are going to plot the torque, on x-axis we are going to plot theta. So this one is torque and this one is theta. Theta must, let's say we have general description about this theta diagram, and we have a variation of T here in this form. So area under this diagram is called as work done, and work done by flywheel. So if this one is theta 1 and this one is theta 2, then flywheel work done can be obtained from T theta, from angle theta 1 to theta 2. This indicates that we have taken a very small strip of equals to what? Height equals to T, and this is d theta is this concept. This one is d theta and this one is a rectangle of such small strip. If you are able to calculate this area, and we can add this area like this, we are able to calculate the total area in this fashion. This part can be done by the integration term. So this concept is same as area under xy graph. We have integral of what? Y dx. Y is this and dx is theta. So if this area was equated with a rectangle of this height, then will you going to call this height equals to mean torque? In that case, the area of this complete diagram must equals to area under rectangle. So we can say that T mean, or we can say the total work done, Tm multiplied by theta 2 minus theta 1. So theta 2 minus theta 1 is the base, this one is the base, and this one is the height. And if you want to write this, you can write this in mathematical form as Tm integral of d theta from theta 1 to theta 2. And therefore, using these two terms, can we find out mean torque anytime as integral of t times d theta divided by integral of d theta from theta 1 to theta 2, from theta 1 to theta 2. So this is how we can calculate the mean torque. So mean torque is always given by this equation. That is called as Rolle's theorem. The area under Tm, that is area of Tm versus theta, is the power required or power produced by the engine. Whereas area under theta diagram is the work done by the flywheel. Just to understand this concept, let's take here one small fraction. This fraction here. Let's call this point is A, let's call this point is B, this point is C, and this point is D. Now if you look at this point, is this area from this is the work required by the engine. Whereas the work produced by the flywheel is only this much. So is the work required by engine is more, that's compared to what? Work done by the flywheel. Because of this one, what will happen to the flywheel? This flywheel will give the energy, is it correct? And will reduce the speed. But when you consider this from this point C to D to this point E to point F during this part, now this portion, does it represents the energy required by the engine? This portion, area under Tm diagram. Whereas the work done by the flywheel, is it more? Is it more as compared to what? The engine requirement. And therefore, the flywheel will store the energy and thereby its speed will increase. Now to justify this, At this point to this point, is the speed of the flywheel decreases. Is the speed of the flywheel decreases? Why so? Because the power requirement by engine is more as compared to what? Work developed. But if you move from this point to this point and then you come back to E, is the power developed by engine is power developed by flywheel is more as compared to what? Engine requirement. So is the speed of the flywheel will increase. And again from this point, what you observed here is that the area under Tm is more as compared to what? Area under d theta. So will the energy is supplied by the flywheel. So therefore what will happen? The speed will decrease. So continuously during the cycle, the speed increases, the speed here decreases, speed increases, again increases, and then again decreases. So this is what the adjustment is done by the flywheel. So during the cycle, the speed of the flywheel may start maybe maximum, then decreases, again increases, again decreases, again increases, and again decreases. And the cycle will continue. Here is this value will be mean value. Say that this value is 900 and this value is 600. So 900 plus 600, 1500 divided by 2 is a 750, can we call is mean speed. So your value will fluctuate from mean on positive side as well as negative side. To consider this effect, we have to introduce the coefficient of fluctuation of speed. The mean speed is given by omega max plus omega mean divided by 2. The coefficient of fluctuation of speed is defined as maximum fluctuation of speed divided by mean speed. Your maximum fluctuation is from omega max to omega minimum. So CS is defined as omega max minus omega minimum divided by the omega mean. But what is omega mean? The omega mean is defined as omega max plus omega minimum divided by 2. Will it come in numerator? So we have CS equals to 2 times omega max minus omega minimum divided by omega max plus omega minimum. Here I want to find out relation between the omega max divided by omega minimum in terms of CS. So to this I will cross multiply. So what I get, CS multiplied by omega max plus CS multiplied by omega minimum is it equal to 2 times of omega max minus 2 times omega minimum. Then you can collect the term of omega. We'll shift this quantity on this side and we'll shift this quantity. So what do you get on this side? We'll get 2 times omega mean plus CS into omega mean is it equals to 2 times omega max plus CS into omega max. So we can very well take common from this side the value of omega mean, which is equals to what? 2 plus CS. So we get omega mean equal to what? 2 plus CS. And on this side we get omega max equals to 2 minus CS. So can we find out the ratio of omega max by omega minimum? So omega max by omega minimum is always equals to, is it 2 plus CS upon 2 minus CS. So GATE is interested in this form of equation. Normally CS was provided in terms of plus and minus value. So CS if was given as plus minus 1%, it means that is your total band from here to here Is it 2%? So you have to take this value numerically equals to 0.02. Correct? You have to take max and minimum. Max and minimum. Max and minimum is what? 2%. 2% is 0.02. The reciprocal of coefficient of fluctuation of speed is called as the coefficient of steadiness. Reciprocal of this is called as coefficient of steadiness. The coefficient of steadiness is simply the reciprocal of coefficient of fluctuation of speed. In that case, this relation will be just reverse. General construction of flywheel. These are called as rims. These are called as rims. But the maximum mass is at rim. Is it correct? They are never use the solid disc because we required this one. Hollow structure we cannot use. Annulus we cannot use. This one is the same hub on which the flywheel is to be mounted. So maximum mass is it distributed away from the center. So in this case, I is called as mass moment of inertia of the flywheel is normally given by mk square, where k is called as radius of gyration. The contribution of this rim for this one, that is I is total. I is the total moment of inertia. But if I want to find out only for rim, so rim will contribute around 90% of total moment of inertia. The rest 10% will be contributed by these hubs, or we can say the spokes. Only 10%. 90% is situated on outer side. And if you check this one, is this total length from here to here, is it equals to perimeter? This one is perimeter. So is this length, if you open up, is it equal to circumference? So what is the length of this one? So length of this one is circumference. Is it 2 pi r? And if you see the section here, this is the width, and if I draw this, will you get a section equals to rectangle? So if you multiply by this section over the length, can we find out the volume of the rim? So we have a section here. The section is something like this. Is it correct section? This one is we can call as width. We will call as this one is width, and can we call this as thickness? You can label this as A, you can label this as B. Then this is the area, or can we say this is the cross-sectional area? So this one is cross-sectional area is A multiplied by B. And for the given figure, this area is constant. So if we multiply this area with the length, can we find out volume? So volume will be equals to 2 pi r multiplied by AB. And if we know that rho, the density of material for which it was casted in kg per meter cube, can we find out mass of this? So mass of this one will be density multiplied by volume. So this equals to rho multiplied by 2 pi r multiplied by AB in kg. Inertia. In general, mass moment of inertia is defined as integral of r square into dm. So we want to find out the mass moment of inertia of a ring is similar to flywheel. So this one is the thin ring. We can model this one as the ring just by neglecting the mass contribution by these spokes. So we have a mass here, that is this mass. Let's call this mass equals to what? dm. And this mass is situated at radius equals to r. Or we can say radius equals to, radius equals to capital R. So is the mass anywhere you take, is it at constant distance r? So is the value of r here is variable or is constant value? Constant value. So r will be equals to, this r is replaced by r square, is it integral of dm? And is the integral of dm total mass? So value of I for this case is mr square. So if you compare this equation and this equation, then is the radius of gyration is same as the radius r. This time we will consider a solid disk. So if you consider the solid disk, we have a same x and y axis. To solve this problem of solid disk, this solid disk has a mass equals to capital M. But the problem is that is all particles on this anywhere, just they have a different value of radius. So how are you going to compute the moment of inertia for a solid disk? Thickness I have not shown is perpendicular to plane, but this does has thickness. To solve that problem, we take the help of this elemental ring. We have taken here one elemental area. What is the circumference of this area? 2 pi r. What is the thickness of this one? dr. So what is the area of this one? 2 pi r dr. Over this one, I say the mass equals to what? dm. And the total mass equals to what? Capital M. Is it spread over the area pi r square? So from this equation, can we able to find out the value of dm? So value of dm will be equals to m is multiplied by 2 pi r small r multiplied by dr divided by pi r square. So value of dm equals to this one is m, this pi is cancelled. Is it equals to 2 small r into dr divided by capital R square. What is the special about this ring? For this ring, is the mass is evenly distributed at radius equal to small r. So if I able to find out the moment of inertia for this one, is it equals to dm multiplied by r square. That is the moment of inertia of this small ring. And is this total area is consist of such small ring. So I have to compute the total area, total moment of inertia is simply integral of r square multiplied by dm. Right? So let's put this value back. This equals to dm equals to what? M into 2r divided by r square. This is replacement for this term. dr I have not written. First I will write down r square and is it multiplied by dr again. For this one, is it 0 to capital R. So m is constant, r square is constant, even 2 is constant. Does it become r cube? Integral of r cube is r to the power 4. Upper limit is r, lower limit is 0. So is this answer is r to the power 4 divided by 4. This 2 and this 2 is cancelled. One of the r square is cancelled. Is this equation is 1 by 2 mr square. Sigma equals to tensile stress or hoop stress in Newton per meter square due to centrifugal force. Now this flywheel is continuously rotating, so it will going to produce the centrifugal force. In that case, we have the hoop stress produced, and which was normally given as sigma equals to density of material, that is rho, multiplied by linear velocity. Linear velocity is v, and you can find out linear velocity anytime using pi dn by 60. That is called as linear velocity. This one is velocity square. Rho v square is sigma. Sigma is called as hoop stress.